I spoke too soon. I actually want to do number 41 next for a variety of reasons. It's the same kind of idea, but you can see for number 41, we have all this data. Now, again, it's got the little icon next to it, which means, of course, that the data was available online. So I've already plugged it in there, right? Because I showed you guys a long time ago, but I downloaded the Excel data sets, and this was one of them. So I just copied and pasted it in here. Put that in there. All right, so the first thing it wants to know is a point estimate of the mean number of miles on a 4-year-old Hummer. Oops, sorry if you can't see that. And then let me go to the next page just to see what they ask. A frequency histogram is drawn below. Describe the shape. Explain why a large sample is necessary to construct blah, blah, blah. All right, so let's start with the point estimate. If you want an estimate of the mean, what's the best thing you should do, right? Well, the point estimate would be, here, put it here, point estimate of mu. I'll insert the symbol, why not? I got the time. There it is, insert the mu. Close. And again, if you don't have to do that if you don't want to. I'm just doing it for fun. All right, what would be the best guess that we would have for the population mean of all Hummers? Why the sample mean, right? So the sample mean, X bar, is our best guess for the population mean. So that's our point estimate. You don't have to put it here. I mean, you can put it wherever you want. I could, here, fling it up here. Take it a second. There you go. Now it's really obvious. Okay, so that's our best guess for the point estimate. Then it asks us, here's a frequency histogram, excuse me, describe the shape. Obviously it's skewed right, so let me just put that in there. Skewed right. Bold. Then it asks why a large sample is necessary to construct a confidence interval for the population mean. Why indeed? Well, it's all based on the central limit theorem. Since the data is skewed, we need a large sample to ensure the shape is normal, right? It's the whole shape center spread thing. You know, I'm not liking this here. I'm going to move this over here and I'm going to delete these. There we go. That way you can see it all. I know, I'm a little bit meticulous sometimes, but that's the way I roll. All right, now it says to construct a 99% confidence interval for the population mean. Assume that sigma equals 19,000. Alrighty then. So this is where it gets dicey. We need to construct a confidence interval. We want a 99% confidence interval, right? I'm just going to call it C interval. Well, all right. Let's think about this. We've got X bar. It's up here, right? Up here, right? Oh, hey, not that far. Come back. There we go. All right, so X bar is right here. We know that sigma was given in the problem. It's, where is it at? 19,000. We know this confidence level is 0.99. Okay, that means that alpha is 1 minus that. That means alpha divided by 2 is equal to that divided by 2. All right, critical value. That would be equal to norm S inverse of 1 minus that, right? Again, I want the positive one, so I'm doing the 1 minus part to ensure that. All right, so then what's the lower limit? That would be equal to X bar, which is this guy, minus Z, which is that guy, times sigma, divided by the square root of, N, which was how many? 34. There we go. Upper equals this plus Z times sigma divided by the square root of 34. There we go. We got the upper and the lower. We're all set. Easy as pie.